Okay, so today I told you that there are two things I want to talk about. One part of it is on you. You just learn how to use GeoGebra to differentiate a function, even if the function is hard. And everything is expressed in the book, so you read and solve that. There are two things that are left. One is about another notation, which is a very simple lesson. I just introduce you. We usually use prime to to show the derivative, but there are other notions. This fly will actually drive everyone crazy. I don't know. It is flying around my head this morning. Yes. Okay, so do you remember we have this? If I give you a function, a y equals to f of x, we can show the derivative of this function with just simply writing y prime. We can show the derivative of this function writing f prime. But there are two more symbols or notations for denoting a function. This is also a very good notation. So this is d, derivative of f of x. Or you can, if you want, you can also write dv, dy. So all these things that you see on the board means derivative. That's it. Yes.
I've also seen like you can use d over dx.
Yes, I will talk about that one as well. So, but there is also another notation which is called the Leibniz notation. Yes. Which seems a little bit cumbersome, but it is somehow useful. So if you want to show the derivative, one symbol, this is the Leibniz notation, so Leibniz notation, if you write dy dx, it's a little bit strange. It seems like a fraction, and that is also good. Why? Because if I ask you what is the derivative, do you remember the definition? So this becomes the limit of f of x plus h minus f of x divided by h goes to 0, yes? This was the definition here. So if you remember, when I wanted to teach you about the notion of the tangent function, so I told you that here you have x, and then you go a little bit further, it becomes x plus h, and then what you calculate, this length is f of x plus h, and this length is f of x, if this is the graph of your function, yes? So if I ask you, what is this length? You tell me this is h, but I can also simply denote it by delta x, yes? Delta x, delta in mathematics means change, okay? So I would say delta x means the change in x, okay? And then if I ask you, what is this difference in the numerator? So this delta x is your h, because if I ask you how much your x has changed, you will tell me h. So this means delta x, change in x, is h units. And if I ask you how much y is changed, you can immediately answer that, yes? So my first height was this, now my height is this. So if I ask you how much I have the change, you will exactly tell me the numerator. So the numerator is the change in y. So the change in y, I write it by delta y. So if I ask you what is the change in x, you tell me h. If I ask you what is the change in the y value, you will tell me this. In general, if I ask you what is the change of x, I mean delta x. If I ask you what is the change in y, I mean delta y. So in this picture, you see another name for h is to say delta x, another name for this is delta y. So another way, if you want to write it more compactly, we can write delta y, delta x. When h goes to 0, but h is nothing except delta x, so you can say that delta x goes to 0. So if I want to write the definition of the derivative a little bit more compactly, I can write it in this form as well. And that was probably the motivation behind Leibniz notation. So Leibniz notation, you see, is very similar. So first of all, it's a fraction. It's not very strange because the definition of the derivative also somehow involves a fraction. And then the point is that this Leibniz decided to show it as dy dx. Okay? We very seldom we will use this Leibniz notation, but let me tell you that this is also somehow very good. Why? Especially if you have more than one variable in your definition of your function. For example, if I give you this function, 5x squared, if I ask you what is y prime, you can answer immediately. It becomes 10x. If I ask you what is dy dx, the answer is the same because dy dx is the same as y prime. Yes? So here I really usually don't use dy dx because there is no reason to do that. This notation is much simpler to write than that notation. But if I give you in this problem, I give you a equals to a squared x cubed. Okay, so if I ask you how many letters are involved in this definition, you say a and x2. Of course, usually we think x is my variable, okay? But there is no guarantee that, because sometimes, of course, sometimes you need to have a as your variable. So if I just write y prime, it would be a little bit ambiguous here, because you might ask me, are you changing x, keeping a fixed, or are you changing a, keeping x fixed? Yes? I told you that. Usually by convention, we always use x as the x-axis. We don't have a different letter for the x-axis, unless you are working in a different area. For example, in physics, might be usually you choose the horizontal axis to be time, and then you denote it by t, for example. But in mathematics, the horizontal line is always usually denoted by x. Okay? But this is usually. But if you want, you can ask two questions here. You can ask me what is dy and then write dx. And then you can ask me dy and then write dA. Okay? So for this one, it makes sense to use a little bit harder notation. Because based on how I interpret this, the answers are different. Am I interpreting x as my variable? Can I see y? Am I seeing y as a function of x? Or am I seeing y as a function of a? If I am seeing y as a function of x, then I use this symbol. If I want to see y as a function of a, then I use this symbol. Okay? And the answers are different. So here, if I ask you what is dy dx for this function, this means that even though a is also a letter, but consider a to be a fixed number. If a is a fixed number, a constant, a to power 2 is also a constant. And we learned that if I give you 5x squared, if I ask you to differentiate it, you don't care about this constant, you differentiate your function, and then you multiply. And that is the same. When I write dy dx, it means that even though there are two variables involved, but this tells you that x is your real variable, not a. So then it means that I keep a squared here as a constant, and I only differentiate this part with respect to x, which is probably very simple for you by now, and then you write 3a squared x squared. So that is the answer that you get. For the same function, I can also ask you what is dy dA. And then it means that consider y not as a function of x, but as a function of a. So this means that x to the power of 3 should be assumed to be a constant. So you write x to the power of 3 without changing it, but you differentiate a squared according to the rules that you know. And what is the rule? 2 goes down, a to the power of 1. So then it becomes 2a. And then if you simplify that, the answer would be 2ax cubed. And then if you compare this result with that result, you see they are different. So I would say that at least, even though I told you that I rarely will actually use this rule, this notation, but it is good to know about that. Is that clear?
Yes.
So this means that, so here, if in the exam I give you this and I ask you y prime, it means that I am having that convention in the back of my head that x is my variable. But if I want to be very explicit, I can write this or that to differentiate between these two symbols. Okay, so this is good if you see other books and they are using the Leibniz notation. Don't get confused. That is something very simple. So at the end, if someone tells you what is this, you just say this is the same thing as y prime. Yes? Okay, so now the last thing that we want to talk is to go back and talk a little bit about tangent lines. So let me just refresh your memory about what we had before. I told you that this is extremely important to have this picture in the back of your head somewhere so that you can always use that. So if I have a function whose curve is this, and then I give you a point on the graph of the function whose x coordinate is a, and if I ask you to draw a tangent line to this, yes, so here, this tangent line has a k value. If I ask you what that k value is, okay, can you answer me? This is the most important part of the lesson. So what is k? If I ask you to calculate k, the k value of the line tangent to the graph of this function at this point, what is that?
The derivative of f.
Yes, derivative of f calculated at
A.
a. So that's extremely important. If I ask you to write an equation for that, it means y minus. By the way, this point is called the point of tangency. The point of tangency, x coordinate is clearly a, the y coordinate is f of a, whatever f is. And then if I ask you to use the 1-point formula for the equation of a line, and I ask you to write an equation for the tangent line, you would write it as this. Yes? What I am using here, I am using this 1-point formula. Yes? If I ask you what is k, for this problem, k is the derivative, so this is why you see f prime of a instead of k. If I ask you what is playing the role of the x node in this problem, x node is the x coordinate of any point on this line, but of course you don't know all of those points, you only know this point, so I will take a and put it here. And if I ask you what is y node, you will tell me that's the y coordinate corresponding to that point, which is f of a. So this is why this would be an equation for the tangent line. And I usually use this form, which is easier for me. But let me mention something. Here, this point A is the point of tangency. So let me emphasize here, this A is not any point that you like. A is the x coordinate of the point of tangency. That is important. So today, I don't know. Let me give you one very simple example to refresh your memory about this problem, and then I want to tell you the new problem today. Okay, so example, that's just for recap, yes? Let f of x be equals to the third root. Let me make it a little bit harder because you now have more tools in your hand. So let me write 3x squared, the third root of x. Determine an equation for the straight line that is tangent to the graph of this function at the point on the graph whose x coordinate is 8. Okay, so that in principle you should be able to solve this problem. And that is, by the way, an important example. So this is an important part of this lesson of derivative. That is the motivation of learning about derivatives. Okay, so what I have to do, if I want to find an equation for the straight line, it is on the board. So I need to put a number for f of a, I need to put a number for f prime of a, I need to put a number for a. And if I ask you what a is, I have mentioned here, the x-coordinate of the point of tangents. So if you read the problem, you realize that what is playing the role of a in this problem, what is that? It's 8, yes? So then, f of a is clear. So f of a that I need on the left-hand side is nothing except f of 8. F of 8 means go to your function, replace x with 8 everywhere. So what happens? It becomes 3 times 8 squared, the third root of 8. So this becomes 2, 6, 64. So how much is that? Yes. So this is 64. If I multiply it by 2, it becomes 128. And if I multiply it by 3, it becomes that. Yes. So this is f of a. So a I know, f of a I know. The only thing that's left for me to do is f prime of a. But f prime of a, so it means that f prime of a is equal to f prime of 8, I have to answer that. But to answer f prime at a number, I have to find the derivative, and then after that I replace x with a. Yes? So the whole point here is to calculate the derivative. And the derivative, I hope that you know what to do at this point. So can you tell me, can I start? I don't have the formulas in here. I think the formulas are not hard. So I think you can remember them. So what can I do here if I want to differentiate that? That was a previous lesson and it was important, yes?
I would rewrite the third root of x to the power of
Exactly. So you want to write it as one exponent, yes? So then it becomes 3x squared. Instead of a third root of x, I just write x to the 1/3. And then I know what is the rule. The rule is that I write x and I add these two numbers, and you can do it in your head and you have to keep it exact. No calculators here. Because 1/3 can be just approximate. It's extremely important. If you approximate that, I will not be able to give you any points. Okay? So 2 plus 1/3, which is how much? 7/3. And I don't think you have any problems with adding these numbers, yes? Because instead of 2, you can write 6/3 plus 1/3, which is 7/. That's a scratch board. Okay, and then everything is ready. I can differentiate it right now. So what is f prime? I know the rule. If I have a constant multiply the function, I know the rule. I don't do anything with that. 7/3 goes down. x to the power of 7 over 3, 1 unit less. Okay, first of all, this 3 and that 3 are cancelled. So what is left for me is 7. And x to the power of 7 over 3 minus 1 is 4 over 3. So it becomes 4 over 3. Of course, you can stop here, but I told you that let us simplify that. You learn that what to do. Yes, you can write the third root of what? X to the 4. And you can still simplify it even more. How? Because the third root of x to the 4 means x to the power of 3, the third root of x. Do you agree? That is exactly the same thing. Why this is useful to write it in that way? Because then this is just simply x. So then it becomes 7x, third root of x. I would prefer to stop here, but of course differentiation is finished here. Why is good to finish there? Because now I want to answer something. The goal of this exercise is not just to differentiate. I want to do something with my derivative, yes? So what I do, I replace x with 8. Instead of x, I put 8. Becomes 112, yes? This is the third root of 8, which is 2 times, this is 56. That's correct. Now everything is ready. So I go and put everything in that formula. So y minus f of a, which is 384, is equal to 112 x minus a, which is 8. In principle, it's better to simplify that. So y minus 384, I multiply 112 in, so this becomes 800, and that one is 96, so 896. Yes, and then I move this one to the other side. 2, 1, 5, negative. So that is the answer that you're supposed to. Hopefully I haven't done any miscalculations, but hopefully you understand what is going on. So if you want to find an equation for the tangent lines of the graph of the function, provided that the point is the point of tangency, because I want you to teach the new concept today. What happens if the point given is not the point of tangency? It is still possible to draw a tangent line, yes? So you remember, even for the simplest case as a circle, I can give you this point on the circle and ask you to draw a tangent. You will draw this one. But now assume that I do not give you this point. I give you a point outside of the graph, and I ask you to draw a tangent to the graph. So this is one of them. If I ask you this question, there is another one here, yes? So that is the lesson for today. I want to give you a point that does not lie on the graph, and then I am asking you to find equation or equations for the tangent lines that pass through that point and are tangent to this graph, yes? So that is the lesson for today. Okay, so let me state the problem formally. But before that, do you have any questions here? That is just a standard problem, yes? A function is given, the point on the function is given, the tangent is wanted. Now let us solve this problem. I think I can also tell you with an example, but can you tell me a strategy how to do that? So for example, let us analyze the problem. For example, I give you the curve. Yes, I give you the curve y equals to f of x, but I give you a point which is not on the curve here. I give you the coordinates, both of them. Yes, I cannot just give you a in this case. Yes, because in the previous case, because the point was on the graph, as soon as I give you the x coordinate, you can calculate the y coordinate yourself by putting it in the function. But now this point is outside, so I have to give you both of them. So I give you a, I give you b, and my goal is to find an equation for the tangent line or lines that I can draw from that point to my graph. Yes? So for example, assume that this is the graph that you have, so it means that I want to determine this line. So this equation is wanted. I want you to understand this is not the same problem. Yes? Because here, can you find the slope of that line? Assume that I give you the number for A, I give you the number for B, I also give you the function. But you are not able to calculate the k value as before. Why? Because in the k value, it's on the board, yes? If I want to calculate the k value, I have to put the x coordinate of the point of tangency there. Yes? Not the x coordinate of any point. You see here, this point for the derivative, it's f prime at a, but here in this case, if I ask you what a is exactly the x coordinate of this point. And that point is missing here. That is unknown for me. Do you agree? The point of tangency is somewhere here. It's t. But do I know anything about the x coordinate? No. Do I know anything about the y coordinate? We don't know. But instead, we know a and b. So we need to learn how to use, this analyze is important, this analysis is important. So you need to understand how to use this piece of information to solve the problem. Okay, I want to hear from you. Do you have any ideas how to do that? Yes?
So we could start off by finding the derivative of the function. Then we could set up any equation to find the point where...
No, but you need to be careful. It should be practical. So if you tell me I start with derivative, okay, I will start with derivative. I take the derivative, now the derivative is in my hand.
Yeah.
Then what should I do in a practical way? Yes? So how should I do that? Okay, now I have my derivative. Then what? Step by step. You need to guide me step by step. Can I put a here and be happy that this number is the k value?
Yes.
Yes or no?
No.
No, we cannot. Yes, because a is the x coordinate of a point, not the point of tangency. That is not working. So what should I do? Yes?
Use the 1 point formula.
Okay, but for 1 point formula it's on the board. Okay, so here you are telling me that, okay, yeah, that's good. Let us start from that 1 point formula. So let us see what is missing, what I need. That's good. So here in 1 point formula, do I have a candidate for x naught in this problem?
Yeah.
What is that?
A.
A. Because I told you that it doesn't matter what you put for x naught and y naught. They should be coordinates of any point on your line. Here you had the point of tangency. You replace them with the coordinates of the point of tangency. Here you do not have the point of tangency, but instead of that you have an extra point. So you can use that. That's good. So instead of y node, I can write b. Instead of x node, I can write a. And I told you that a and b are given, so this is done, this is done. But unfortunately, this question mark is still left. So still, we want to find the k value, but in this new setup. How should I do that?
So the k value is just the derivative, right?
The derivative at
Point.
the x coordinate of the point of tangency. That's it. You cannot say that the slope is just the derivative. Derivative is a function. A slope is a number. So you need to find a number. They are related. You differentiate, you find the x coordinate of the point of tangency, put it in the function, you get the number, that number. But that is missing here. I want you to at least understand the problem. Yes? The problem is not as simple as before. We need to find a way for it. Any ideas?
This is just a thought, but from what you did previously with the derivative, can we take that, or no, it wouldn't work, Okay.
Any other ideas? Okay, let me guide you. The guide is to pretend that you know t. Pretend means what? For example, I don't know, if I ask you, do you know the coordinate of x? T, I say no, but let me pretend I know. For example, let me put it alpha. Okay? But if I put it alpha, the y coordinate becomes f of alpha for sure, yes? I don't know alpha, but there are not two unknowns, because alpha, if I know alpha, the y coordinate is f of alpha automatically, because the point of tangency also lies on the curve. But still, this is missing. Okay? So, it means that I will not follow this strategy, even though it was very reasonable. I will follow my strategy as before, pretending that I know alpha, but of course I don't know alpha. I need to solve it later. So now forget about the problem. Can you tell me, forget about this piece of information, pretend that you know alpha. Then how do you solve the problem for the equation for this? You would write it as y minus, can you help me?
F of x.
F of
F of alpha.
And what can I write here? Alpha.
Yeah.
What can I write here?
A derivative of f of alpha.
Alpha. But of course, this is not solving the problem, because still the point is that what alpha is. We don't know. But if we pretend that we know, I hope that you agree that would be my equation. Yes? Okay. Now, how can I exploit this information now? So far, I haven't used this piece of information given the problem. Okay? So, if I ask you how many unknowns are left for me here, alpha is the only unknown for me. And then one piece of information is provided for me in the problem. So using that, I should be able to find alpha somehow. Yes?
So you put a and b in y and x.
Exactly. So instead of b, because you say that whatever this line is also passing through this point. When it is passing through this point, it means that the coordinates of this point should satisfy the equation of the line. So it means that if you replace y with b, and replace what? X with a, this should hold. I want you to understand the idea. And now if I ask you what is the unknown in your equation, there is only one unknown left for you, and that is alpha. So then it means that you find alpha, and when you found alpha, you put it back in this equation, you are done. Okay? So let me just review. Of course, this seems a little bit abstract, but if I want to give you functions and numbers, it becomes very easy. But I want you to understand the logic behind that. So here, first of all, I want you to understand why there is still a problem in this new problem. Is that because if I want to find the k value, I have to differentiate and put the x coordinate of the point of tangency to get the k value. I don't have the point of tangency, so the old method has to be modified somehow. This is not directly applicable. Yes? So then, what I told you, even though this seems right, what Abdullah mentioned was right, but it was not working because I still don't know how to calculate k. So I changed my strategy. I said that, okay, let us pretend to know t. Pretend to know t means that, okay, the x coordinate is a number alpha, and its y coordinate would be definitely f of alpha. And then let me write the problem as before. So I wrote this formula for the equation of the tangent line. But that was just pretending. I really don't know alpha. I have to find it if I want to solve the problem, yes? So what I use this piece of information. I know that whatever this line is, this is supposed to pass through the point A. So it means that the coordinates of this given point should satisfy my equation. So I replace y with b, I replace x with a, then I solve this equation, and I hope that I can solve this equation and find alpha. As soon as I get my alpha, I put it back in this equation, that's the equation of my tangent line. Yes? So let us use this trick for a practical problem. Yes, I give you a simple exercise first. So example, let us just do this example, if I can visualize it. So I would say, consider the function. Let me make it very simple first. The function f of x equals to the parabola x squared, the simplest possible non-trivial function, of course. Determine an equation for the lines, or line, I don't know how many of them are there. Determine an equation for the line or lines that passes, I don't know how to write, passes through the point. So I want to give you a point that is guaranteed not to be there. So let me write A, 1 and 2. And let me make it a little bit larger if we want to demonstrate it using algebra. It would be easier. So let me write 1 and 4. No, I have to be careful very. So I have to write it 4 and 1. 4 and 1. Yeah, that is more reasonable. So consider the function f of x equals to x squared. Determine an equation for the line that passes through the point that and is tangent to the graph of f of x. Determine the coordinates of the point of tangency First of all, if this is given in the exam, how do you know that this is the new lesson and not the old lesson? Because it seems a little bit similar to the previous setup. So how do you realize this is the new lesson, not the old one? Yes?
Well, it's saying the line that passes through the point and is tangent to the graph. They're not saying the line, the point of tangency.
No. So I can also give you the point of tangency. Then I can give you a point here, and I ask you to draw a line that passes through this one and tangent to this one. That's also possible. But there is a better reason why this is a new lesson, is that this point does not lie on the graph. How do you understand? Because if I put 4 instead of x, the value of y is supposed to be 16, but the value of the y is given to be 1. So it means that this point, the coordinates of this point, do not satisfy this equation. So it means that this point is outside of that graph. That's also one way, yes, to understand that. Okay, and the reason that the previous point didn't work, can you guess why? Why I changed it from 1 to 4 to 4 to 1? Because if you have a little, you know what is this graph, yes? At least you have some ideas. This is the parabola, yes? 1, I get 1, minus 1, I get 1, yes? And then 0, 0, so that is something similar to that one, yes? The previous point that I mentioned was 1 and 4, yes? What was 1? Where was 1 and 4? I realized that 1, 4 should be somewhere here, yes? Yeah, and from that point, intuitively it is clear how many tangents I can draw. Can I draw a line that passes through this blue point and tangent to this curve? No, because it's inside, yes? It is not working. So then I realized that if I ask you to do that, you have some problems with finding that. So I changed the coordinates. Now the coordinates are 4 and 1. 1, 2, 3, 4, and 1. Of course, it is still probably not intuitively clear, but yes, I think it is clear. Yes, do you agree? It seems that I can draw a line, at least one. It might happen that I can also draw something up there, but let us see, we don't know. Okay, I'm just telling you that why I switched my opinion from 1-4 to 4-1, because the previous one was not probably working. Okay, let us understand the problem. So let me write this point here, 4 and 1, and my goal is to understand this tangent. I don't know where the point of tangency is. I told you that. Pretend that you know it. Pretend that you know it means you write the alpha, but can you tell me what should I write for the y coordinate? F of alpha. In this case, f of alpha is? What is f of alpha in this case?
Alpha squared.
Alpha squared. So definitely it's extremely important. I could write alpha and beta, but I am making two unknowns for myself. So try to keep the unknowns, the number of unknowns as low as possible. Any questions? So I am pretending that I know the point of tangency by giving the x-coordinate to be alpha. Then I have to follow the function. If the x-coordinate is alpha, and because the point of tangency is on the graph, so the y-coordinate should be alpha squared. And then what I need my derivative. I pretend that I know this. So it means that the k value is what? Is f prime of alpha. So it means that I have to calculate the derivative, but this function is very simple. The derivative of this is what? What is the derivative? 2x. And I want to find k value. So the k value is f prime of alpha. F prime of x is 2x, so f prime of alpha is nothing except 2 alpha. But if you ask me, do you know the value for k? I would say not yet, because I don't know alpha. I just pretended that I know the alpha. But that is good enough, because of this analysis here, yes? So here what you do, you write y minus f of alpha, which is alpha squared. What is your k value? Is 2 alpha. X minus x value alpha. But I am not done yet, because still alpha is missing. I have one extra piece of information in the problem. I know that this line is supposed to pass through this point. So what does it mean? It means that the coordinates should satisfy this equation. So instead of y, I put 1 minus alpha squared is equal to 2 alpha, x minus alpha. Oh, sorry, x, no, sorry. What I did. Sorry. Instead of x, I have to put 4. So this is supposed to be my tangent line. The problem is not solved yet because I don't know alpha, but I know that the coordinates of this point should satisfy this equation. So instead of y, I put 1. Instead of x, I put 4. Then if I ask you, what is the only unknown in this equation? That is alpha. I solve this equation and find alpha. Yes? This is simple to solve, isn't it? So you can just multiply this in. So this becomes 1 minus alpha squared is equal to 8 alpha minus 2 alpha squared. I moved it because I realize this is a quadratic equation. So I need to use ABC or PQ formula. So I move it to the right. It becomes positive 2 alpha squared minus alpha squared. This is just alpha squared. I move this to the left. Becomes minus 8 alpha. And then I will have 1 equals to 0. I have to solve this one. So alpha becomes minus b, which is 8, plus or minus delta. Here is 8 squared, 64, minus 4. Of course, the numbers are very bad here. So 2. This becomes 8 plus or minus the square root of 60 divided by 2. I can simplify it a little bit. square root of 60 is square root of 4 times 15. Square root of 4 is 2. So this becomes 8 plus or minus 2 square root of 15 divided by 2. I can factor the 2 out and then simplify that. So this is a little bit nasty numbers, but this is what it is. So that is my unknown alpha, yes?
Is the factoring out the 2 part obligatory or?
No, I would prefer to make it simple because that's already ugly.
Okay.
So,
But square root of 60 is fine if we keep it like that.
But then you can keep it like that, yes.
Okay.
So that's your alpha. Okay, and then I was expecting to find alpha. I got 2 answers for alpha. So what is the interpretation of getting 2 answers? Yes?
There are 2 possible lines you can draw.
Yes. I have 2 points of tangencies. So it means that definitely there is another one which is probably I cannot see in this bad picture. If you want to make it precise, you'll probably be able to see it. But there are 2 things I wanted in the problem. Find the an equation for the line. So what I have to do, you have to bring it back and put it in this equation. So I would say y minus, a very bad example because of that unfortunate number. So this becomes plus square root of 15. That does not simplify it because it is wasted of time. So 2 times alpha is 8 plus 2 square root of 15, and then I have x minus alpha. This is one equation. Another equation is the same. Let me not write it down, yes? If I want to write it, it becomes negative. So there are 2 answers. One equation is with the positive sign everywhere, and one answer is with the negative sign everywhere. So I think it's a very bad example because of that bad number, unfortunately. But now if I ask you what are the points of tangencies, then it is clear. This is the point of tangency. So what I write, I would write plus 4 plus or minus the square root of 15. It's the x coordinates, or the x coordinates, and then the y coordinates are these numbers to power 2. Yes? Okay, so I don't consider it to be a good example because it might be a little bit confusing because of these bad numbers. Let me choose the example in the book and solve it once more, okay? This is another example. Okay, so I don't write so much here now. I just write the function and the point here. Because these numbers might be distracting, you will not be able to see what is exactly going on. So here, I do the same thing, but this time I give you this function, 1 minus x squared, and then instead of point A, I give you these coordinates, minus a half and 3. So the question is exactly as before. Change the function from that function to this function, change the point to this point. How do you understand this is the new problem today? Because if I put minus a half here and calculate it, it will not become 3. So it means that this point is not on the curve, it's somewhere else. Yes? So this means that this is the new lesson today. Okay, let us review what we are supposed to do. I pretend that I know the tangent point of tangency. How? By writing t, for example, alpha. And can you tell me what is f of alpha in this case? What is f of alpha?
1 minus
alpha squared.
1 minus alpha squared. This is pretending that I know that. If you pretend you know that, you don't have any new problem in your hand. You just do it as before. So it means what I'm supposed to do, I have supposed to calculate the derivative as I did before. It becomes 0 minus 2x, which is just minus 2x. And then I calculate the k value, the k value, I use alpha that I pretend to know. By putting alpha here, it becomes minus 2 alpha. Then I write my equation, 1-point formula, y minus, okay, I want you to fill up the gaps for me. Okay, can you tell me what I should write at this stage? I am pretending that I know this point, and I pretend that I know my k value. So the first question mark on the left should be, tell me, what should I write for the first question mark?
1 minus x.
1 minus?
1 minus alpha squared.
1 minus alpha squared, exactly. But don't forget, if you write like this is wrong. You have to put a pair of brackets around that. Instead of this third question mark, what should I write? Alpha. And instead of this middle question mark, what should I write?
Negative 2 alpha.
Negative 2 alpha, which is my k value. So you see, the problem is very simple, but you should work with an unknown alpha. So this is your supposedly equation of the tangent line, yes? Now alpha is missing, and I can use this extra piece of information. This point is supposed to lie on this line, so it means that the coordinates of the point should satisfy the equation of the line. So I replace y with 3 minus, and I replace x with minus a half. And then my duty is to solve this equation and find alpha. Exactly what I did before. But according to the book that I see, the answers are friendly here. That's good. Okay, so let us solve that equation together. So that is very simple Math 2C problem. Yes, so I multiply this negative sign in. I multiply minus 2 alpha in. It becomes this minus a half and this minus 2 are cancelled. So what is left for me is just simply alpha. And then minus 2 alpha multiplied by that one is positive 2 alpha squared. Then you see that that's a quadratic equation, so it becomes alpha squared, 3 minus 1 is 2, is equal to alpha plus 2 alpha squared. I move alpha squared to the other side, 2 alpha squared minus alpha squared is alpha squared. I have alpha there. I also move 2 to the other side, it becomes minus 2 equals to 0. And this is the equation that I got was this one, but the numbers are actually a little bit nasty. But now the numbers, as you see, they are nice. But the problem is the same. Yes. So here, if you calculate this, alpha becomes minus b plus or minus square root of b squared, which is 1, minus 4 times a times c, which is 8, divided by 2 times 1, which is 2. And then this is 1 plus 8, 9, which is a nice number. This becomes plus or minus 3 divided by 2, so I get 2 answers for alpha. Okay, so what happens is that this becomes minus 1 minus 3 divided by 2 is minus 2. Minus 1 plus 3 divided by 2 is how much? It's 1. But you shouldn't stop here, because my goal is to write an equation for the tangent line, and don't get confused. You have to go back and replace it here. So if alpha is minus 2, then put minus 2 here. We can do it in our head, yes? 1 minus 4 is minus 3, so it becomes positive 3. If I put minus 2 here, it becomes positive 4. And if I put minus 2 here, it becomes plus 2. And then simplify it a little bit. So y becomes 4x plus 8 minus 3 plus 5. So that is one of the equations of the tangents. And then if I put alpha equals to 1 in the same equation again here, alpha 1, this will cancel with this one. So this becomes y equals to minus 2x minus 1. And then I prefer to multiply it in, so you get minus 2x plus 2. If I ask you what is the point of tangency for this line on the graph, you have to put minus alpha here in the point of tangency. Yes? So this means that the point of tangency here, alpha is minus 2. And alpha minus 2, it becomes 1 minus 4 is minus 3. And then the other one, if I have it here, the point of tangency for this line, I have to put alpha equals to 1 there. So it becomes 1 and 0. So it means that if you use GeoGebra to draw the graph of this function and draw the graphs of these two lines, both of them will be tangent to this graph. Both of them will pass through this point, but the point of tangency for this one is this point, the point of tangency for this one is that. Yes? So that is what I want you to learn in this new lesson. There is another method for doing this. It is not in the book. It is what usually Cambridge A-level questions, they ask you to solve it in this way. And that is not related to derivative at all. So you can solve it in a different way that you really don't need to do any derivative at all. So without derivative, you can also solve this problem. But it becomes, you need to be very careful how to do that. Yes?
Is it easier?
Let us see. I don't remember, but we can check now. I can solve this problem, which was a nice problem, using this method to see how it goes. Yes? Especially this will work if you have parabolas. If you have higher degree polynomials, this somehow will work, but then it becomes harder for you to understand. But if the function given is a parabola, I would recommend you can also learn this new trick to solve that one. But this is not related to the derivative at all. Can you imagine now how we can solve the problem for a tangent line without even thinking about the derivative? Because still you understand that we want to find the k-value somehow. Is there any way that I can find a k-value without derivative? We don't know yet. You need to discover, yes?
Maybe. Could it be that instead of the derivative, we could write, since it's a straight line, delta y over delta x? In the 1.4.
Okay, but the point so if that was the case, why we should go to the yes, you are right. In principle, yes, but the problem is that we need 2 points for writing that value.
Well, if we pretend that we know the 1 point like we did.
Now then it will become something like this.
Okay. Okay.
And then you have to use the derivative of that.
Okay.
The idea is a clever idea, actually. Yes.
No, I was just thinking if you find another point on the same line, then you could find the k value.
No, might be you are not in that line. Let me at least put you in track, then you can answer. Okay, so let me give you a parabola. Okay, so for example, this is your parabola. And then I give you a point outside. This analysis actually is very important for you to understand. How many lines are passing through this point A, regardless of looking at the parabola or not?
Infinite?
Infinitely many. Yes, so infinitely many lines are passing, yes. This one, I don't know, this one, and even very particular one, yes. That is tangent here. Okay? Is that right or not? So there are infinitely many points passing through this point.
Yeah.
Some of them might not intersect this parabola at all. Some of them will intersect the parabola exactly at one point, which is my target. I want to find those because those are tangents, yes? Or there are some lines are not tangent, they are intersecting more than one point, and that's a secant line. So among all these lines, I want to find those that intersect. You see, I am emphasizing on intersect, not tangent. I want to find those lines which intersect with my parabola exactly at
The point of tangency?
how many points?
1.
1. So you see, I am not using the notion of derivative at all. I am using the idea of intersection. So it means that there are infinitely many lines. Let me ask your help to do it. Let us keep the problem here on this board, and then we can understand how it goes. So let me ask you this question. Can you tell me, if I want to write an equation for all the lines passing through point A, what I am supposed to do? Okay. Here, I would write y minus y node equals to the k value x minus x node. This is the formula. But now I am interested in all these lines that are passing through this point. I don't know the k value, so let us keep the k value for the time being. But I know something about x node and y node. What are they? The coordinates of that.
Yeah.
Agreed? Then it becomes y minus 3 equals to k x minus minus a half, which becomes 1 over 2. Yes? So if I ask you, what is this equation representing? You will tell me that this equation represents all the lines passing through the point A. Yes? Understandable or not? Except the vertical line. The vertical line doesn't have any k values. Yes? Okay, but then some of these lines will go and intersect my parabola at 2 points. This is, by the way, a parabola. Some of them will not intersect the parabola, but some of them, or one of them, I don't know how many of them, will intersect my parabola exactly at 1 point. If I ask you, can you find the intersection points? Do you remember what we are supposed to do? This is the equation of my line. Let me write it. Y is equal to kx plus k over 2 and then plus 3. This is the equation of my lines. And then I have also my function y equals to 1 minus x squared. Yes? If I ask you, I'm asking you find the intersection points. Do you remember what we are supposed to do? This is a very generic question. I give you 2 graphs and I ask you find the intersection points. How do you do that? Yes? System of equations. Don't hesitate. These are some standard things you need to know. So I put them in a system of equations and try to solve it. The goal of this is not derivative at all. I am finding the intersection points. Yes? So it means that I can equate y's. So this means that I have y 1 minus x squared is equal to kx plus k over 2 plus 3. Let us get rid of this fraction by multiplying by 2. 6 plus k, or k plus 6. Yes? And then let us, this should be equality, sorry. I multiply everything by 2, I get this one. So let me move these to the right. So it becomes 2x squared. I have a 2kx here. And what I have k plus 4. Yes? So what I did, I wrote all the equations for the lines passing through this point only. And then I intersect these two to find the intersection points. Understandable or not? So if I solve this equation, can you tell me, if I solve this equation and I get x, what are that x? What is that x? What is the geometric meaning of that x? Can you tell me?
Bob, like, how did you get positive 4?
I moved 2 to the other side.
Okay.
So can you tell me, if I solve this one and find x, what is the meaning of that x that I have found?
The common x.
What is the meaning? Can you tell me?
The x that is on
The x coordinate of the intersection point. Yes? Is that clear?
Yeah.
But how many intersection points I need for my problem?
One.
One. So it means this is quadratic equation. There are three possibilities for a quadratic equation. You remember? If delta is negative for this, how many solutions do I have?
0.
Nothing. But I don't want to have nothing. If delta is equal to 0, how many solutions do I have? One. And I exactly want this because I want to have one intersection point. If delta is positive, then how many intersection points I have? Two. I don't want it. So it means that I want to have one intersection point, so it means that delta should be equal to 0. Yes?
Yeah.
So what is the delta of this? This number is playing the role of A. This number is playing the role of B. And this number is playing the role of C. And then it means that B squared is delta is B squared. Yes, let me write. Delta equals to 0. This means B squared minus 4AC should be equal to 0. B squared is 4K squared minus 4 times A times C. 4 times A is 8. Yes? But you see, I can simplify everything by 4. This becomes K squared. This becomes minus 2K. And this becomes minus 8. Again, I have to solve the quadratic equation. But here, I solved a quadratic equation which is different from this equation, by the way. When I solve this quadratic equation, I get the x-coordinate of the point of tangency first. But when I solve this quadratic equation, I get k value first. Okay, so that's good. So, what do you expect for k value? Can you tell me? What do you expect for the answers here by looking at the solution here? The k values are how much? 4 and
-2.
1 minus 2. Let us check. So if I calculate this, k becomes minus b plus or minus the square root of b squared. 4 times that, it becomes 32 positive divided by 2. But this becomes 36, 6 divided by 2. So the k values are what? 6 plus 2 divided by 2 is 4. K, 2 minus 6 divided by 2 minus 2. They are exactly the k values. So did I use derivative? No, nothing in this solution. You don't see any derivatives, but I was able to find the k values. And the k values are confirmed by the previous calculation here. So is that understandable? So that idea is also very helpful. Okay, you can have it in the back of your head. If you use this method for the exam, that's okay for me. But this is not the method given in the book. Usually in Cambridge A-levels, you need to know this. So this is exceptional. So we can find a k value from a different perspective, but just for these parabolas. Yes, why for parabolas? Because delta makes sense for quadratic equations. And in quadratic equations, I need to have intersection. I need to start with the parabola. So if that is a higher degree polynomial, then I will end up with a higher degree equation here, which I don't know how to treat. But if this is a parabola, I know what to do. So if you want to solve that problem for a parabola, you have two methods. One using the notion of derivative, one completely independent from the derivative. So you see, for this problem, you really don't need to solve to know the derivative of the function. Of course, the problem is not finished. When you find the k value, you have to put it back here. Let me just do that one here. For example, if k is 4, let me put it here. Y becomes 4x, 4 divided by 2, 2 plus 3, 5. And that's exactly that equation. And then you put minus 2 back here, then you get your equation. Yes? Important. So this kind of skill, I really want you to learn. We are analyzing the problem. This skill you need to learn, even if you don't want to use it, but I want you to understand why this method should work. Understanding this, why this method is working, is extremely useful for you. Any questions? So this chapter is officially finished here. I will update the Google Classroom, which parts you study and whatever, and then we have to accelerate a little bit. Okay, so let us see how it goes. There are very good questions. There are two, I see there are double star problems here, especially towards the end of problem listing. So I will update the Google Classroom and then you can start working on it. Any questions? Yes?
You only put in 4. Shouldn't you also put in -2?
Yes, yes. This is what you put. So what I'm saying is that here in this method, you first find the point of tangency and the tangent line.
Yeah.
Here you find the k values, but you have to put it back to find the tangent line. Yes? But of course the weakness of this method is what? Can you tell me?
If it's not a parabola.
So yeah, that is one weakness. The second weakness is that you don't have a good, so you need to calculate a little bit more to get the point of tangency.
Yeah.
Because you just get the k value and then using the k value you write the equation. But you see the point of tangency is missing in this calculation. So if you want to find the point of tangency, what you're supposed to do, you need to put k value here and find x. Then you get the point of tangency.
The interesting thing is, you have that quadratic equation with ABC, but you just leave it.
Yes.
Yeah, you just use it to find the k value.
Yes.
Yeah.
So you don't need to solve this one, which would be a mess. You just write the delta, but delta becomes a very simpler quadratic.
Okay.
Okay, thank you very much.
Tekniken ute. Det gick ut. Vill inte gå.